Microphone turned on. So let's start again. Hi everybody, let's start again. We're working on a Centipede board today. If you haven't been to this channel before, this is an arcade re-repair. And basically I'm going to be taking a circuit board that I have repaired and I'm going to unrepair it by putting all the chips back in. Sorry, I've already done this. And we're going to start fresh, but we're going to go through my whole idea of how I came to each step, how I went through this whole thing, and hopefully you guys will learn something that you can take away. So let's go again to the board. Okay, so this is a Atari Centipede. Basically what we have here is you've got your CPU, which is a 6502, and a pokey chip, which controls some audio and some controls, like I believe it actually works with the trackball. We have the ROMs over here, and we have the graphic ROMs over here, a bunch of video RAM up top, then we have the control circuitry over here, audio output there, and some video stuff there. Thanks, Arcade Nut. Indeed, I did turn it off and turn it back on again because we started the video over basically, so we're all caught up now. Okay, so here's what we're going to do. We're going to start off by making sure the board doesn't have a dead short. So this is something I always like to check when I start with a board. Basically, I want to just use my probes between 5 volts and ground on the board somewhere just to make sure that it's not actually shorted. So I'm going to take a chip I'm familiar with. So say this 86 down here. I'm just going to check across the rails. You're looking for a low number here, so 9.6 makes sense. If it read 0 or say less than 1 ohm, we'd be in trouble. But we're not, we're fine here. So this board probably isn't gonna blow anything up when we plug it in. So I have an adapter here that I've rigged up. These are my own adapters that I make, that I use to try and make testing stranger boards easier. So you can see here I didn't quite have the right connector. I only had one that was bigger, so it's kind of stuck on the end there. But I will be plugging that into... Ooh, I can't really move the camera over here. My JAMA adapter that I use here, and I have an RGB monitor that I'm connecting this all to. So I'm going to connect this up. And we can turn on the CRT here. And so if I'm going to turn it on over here. Okay, so I got 5 volts on my regulator. The LED came on the board. If I just get rid of the CRT for a second, you can see the LED over here. But as you can see on the CRT, we have nothing. The CRT cam is working. There's my fingers in front of it. We have no video at all. So usually what I would do here is I would start by taking a look at the sync line. So I bring up the oscilloscope now. So the first thing I would check is the synchronization line to see if we are getting clock kind of all the way to the end. The sync is generated from a bunch of different clock signals and video signals on the board. So I like to check there. So I'm actually it's gonna be off camera here, but I'm checking the actual sync signal on my thing here. I'm gonna just make sure that there we go. So now my oscilloscope display is working. So you can see there, slow to update, but we've got nothing there. So it's basically 0. So we're not getting a clock signal through this. Arcade Nut, I don't actually sell these adapters. I don't have very many. I tend to order about 10 at a time. I'm happy to kind of give away the files if you want. There are some other prototyping ones that are pretty good. I can, send me an email after or PM. I'm not sure if there's private messaging on YouTube. Send me a message and I can probably hook you up somehow. Yeah, it has adapters on the side. It has spots for connectors so you can do all sorts of off-board things, because obviously in the earlier days especially, they didn't just have one connector. They had 2 or they had 3 or they had stacks of boards with connectors all over the place. Okay, so we are now going to move on to figure out what is going on with our sync signal. So I'm going to switch over to the schematics for a minute here. So if you don't know this website, arcarc.xmission.com, it's an amazing repository of schematics and manuals and everything. So I've opened up the Centipede drawing package, 5th printing, AB, and AB here. So I'm going to take a look here, and if we go all the way to the last one, we can look and see where the sync signal is actually coming from at the end here. So here's our video output circuitry. So composite sync is down here. You can see it's number 12 on the pin header, but that comes from A9. So I checked this was dead, this was dead. But then we go back to here, so B7. Take a look at this, we'll look at this chip B7 here. B7, where are we here? B7 is right here. So we'll take a look at B7. And that was pin, so 1 should have VSync on it. We got nothing. So what you would expect there is a signal of roughly 60 frames per second, and we got nothing there. Okay, we'll take a look here on HSync. Oh, and we do have something. Hold on, I turn on auto refresh. There it is. Okay, so we do have a signal on the HSync. So we know that there's something going on. But again, this number doesn't make any sense. This is showing 47 kilohertz. Let's see if I can make sure this goes quickly here. Okay. 47 kilohertz is not the right number. You're expecting to see 15 kilohertz more than you would ever see 47. It doesn't make sense. Okay, so we know that our clock chain has issues. Something is wrong with the clock. So we're going to go back and take a look. Crystal, Arcade mentioned the crystal here. There's 2 spots on here to put a crystal on. I think it's because they broke off and I don't know if they changed what they used. There's 2 that are connected. So yeah, you'll find skinny ones, the really skinny legs, and they break off. And I think they were later replaced with these thicker ones, the same type that you would see in a Space Invaders board. So this one has one and it's nice and snug. Okay, so instead of working on the end here, I'm going to go back to the beginning. Let's go back to the beginning of the schematics here. So, synchronizer. So, most arcade boards start in this way. Most arcade boards start with a crystal, with a couple of capacitors around it, and then it goes into something like a 7404 of some sort, an inverter, and it basically creates a alternating signal that goes up and down in a really resilient way. And then that basic signal is then passed through all these different counters to generate all the different signals on the board. So here we can see that we have our crystal here, and if we look on the board, bring this down in here, this is the crystal up here, and it's looking fine. Now I'm going to stop for a second, and I'm going to skip ahead a little bit because there's a smell. I can smell that a chip is burning on this board, and this is one of the things that is the reason I don't do these re-repairs on customer boards is because I'm putting my own boards at risk when I redo these. So there's a chip on here that I know is running hot, and I was actually hoping I could get a little thermal camera or something to show you this, but this chip right here, this one, ooh, I'm blocked. This chip down here, this 175, is actually really hot, and I can smell it. So I'm going to skip ahead, and I'm going to remove it now. So I'm going to turn off power. I'm going to grab my IC remover. We're going to remove that. And now this chip actually runs the high score, the EA ROM thing beside it. Okay, so that was burning. I'm just gonna remove it now, and I'll put in a I'm gonna put in its replacement. Where is its replacement here? No, it's not the right one. I think I'd be happier to have this board not burn up. So there's a 74-175. I'm not going to go over to the testing board yet. We can go back there. So I'm going to just pop that in there. Make sure it's the right way around. Put a sticker over the notch. Okay. There. No more burny smell. Okay, back to the schematics here. So I am getting a clock signal out to here. And so what I want to take a look at is the clock signal getting into this first counter? and are we getting these out? So you can see here, so we got 12 megahertz going in, we have 6 megahertz coming out, then we have 1H, 2H, and 4H. So those numbers refer to the horizontal scan lines. So that is chip P2. So P2 is up here in the corner. Let's take a look at the oscilloscope here. So I'm going to check pin 2, which is the incoming clock. Okay, there, so we have, let's get the oscilloscope up. Come on, baby. There. So there you can see that's 12.096 is the actual value of the crystal, and it is fine. So we know we're getting something in. So let's check on the outputs now. So QA, which is pin 14, should be 6 megahertz. We got our 6 megahertz there. So then you expect QB to be half of that. Come on, where are we here? 3 megahertz, 1.5 megahertz, and 750 kilohertz. Okay, so that particular chip, LS163, is fine. So now we'll go ahead here. We'll see. So that's good. I'm just going to look. I'm not going to go through each one of them here. So I went through, I checked N2. N2 was fine. Then I went to M2. So let's take a look at M2 here. What's going on with M2? So M2, it provides a 128H and 256H. So again, those are horizontal scan lines. If you follow that 256 all the way along, you eventually get to, let me back out here a little bit. You eventually get to, ooh, have I lost it? Where have I? You have V blank, there it is, H-sync, sorry. You eventually get to H-sync. So this is what's screwed up on our board, and V-sync is not working at all. So this is, these are the signals we're trying to get to. So we're just a little bit back here on M2. Okay, so let's take a look at M2. So M2 is right here. And again, we can make sure that we are getting an incoming clock on 2. We are. Now, let's check our output. So the only output that we're interested in is on pin, let's see here. So pin 14 is our 128H. So if I bring this in just a bit so we can see. So that signal looks pretty good there. That looks like it makes sense. But now I go to the next output, and it's dead. Shouldn't be dead. So that should be moving. And it is not. So we got no outputs there. Just for fun, if we want to take a look at the comparator. So a comparator, this is an HP 10529A comparator. So these are really neat. They're hard to find, they're a little expensive. TorontoSurplus.com has one right now for $350 US, new old stock. It's kind of neat. So if you're in Canada and you want to drop some money, it's pretty useful. There's a couple of projects to try and make these new and cheaper. So basically what you do with that, I'm going to take our LS163 that I've tested and it's working. So you put that in the top here, and you can adjust the dip switches to actually, you basically move all the ones over that are outputs. Everything else you leave as inputs. So then how you use it, I'm going to turn the board off for a second just so I don't short anything out. You take the clip and you find pin 1 and you match pin 1 up with the chip. This should work, but it could be a bit of an issue just because it's in a socket. Oops. Okay, so that's in there. So now, when I turn this on, oop, it wasn't on there good enough. If it makes a bad connection, you won't get any result there. There we go. So you can see with the comparator here, so it's on, it's getting power, and you can see that those 3 outputs that I tested are showing that they're off. And yeah, the other, the one that was working that we tested is fine. It didn't show up as a bad signal. So we know this chip is bad. So let's test it as our first chip that we know is bad, because there are some limitations to the comparator. So the comparator doesn't work on anything that has connected bus output. So you may wonder, why did they stop at only 14 or 16 pin chips? There's so many 20 pin chips like 244s and 245s and 273s, and they fail often. But the problem is, the way the comparator works is it takes the inputs from the board and it applies it to the good chip, and it checks the application of the logic on the bad chip and compares them. And if they're not the same, that's when you get the lights that light up. Okay, so let's hop over to the test zone here. Okay, so I'm going to use my Mini Pro. So I'm going to use the Mini Pro. You may know this. Very common. TL866 is the number. This is a very popular one right now. Oh, I've got an error code. Let's see if we can get through this anyway. So I'm going to select 163 as my logic. Select. Then I'm going to take the chip, place it in, like so, and hit test. And it thinks it's normal. So there you go. IC testers don't work very well all the time. I didn't check this in here because I was pretty sure it was broken, so I did not expect it to work. That's very strange. I know it doesn't work, so there you go. IC testers are not perfect. Let's try it in the, I have a DOS tester here. This is a high-low device, high-low systems, all 07. So let's try it in this one too, just to make sure. Make sure I'm not acting crazy. So let's try it here. Function test. It thinks it's okay as well. So what can I say? I know it doesn't work. I tested it. Maybe it doesn't work only at the high frequency of this crystal. Okay, so that was unexpected. I didn't actually test this bad chip in a tester, but I know that it's broken. So I'm going to put the new one in. We're going to check for outputs here. So, board. So we're going to put this in. Okay. I'm going to check, turn it on. So 14 was working before anyway, but now 13. Okay, so check this out. This is interesting. I may have made a mistake, but an interesting one. So that chip that I just said was bad, perhaps it was actually good, because take a look at this. Now on this new chip, change this to the virtual panel. Okay, we're back. Okay, so here's pin 14. Pin 14 was good as we saw before, but look, pin 13, now we're seeing something. It's not 0, but it's still no good. So in this case, we know that this chip is good as well. I'm going to have to assume that it's another chip in this chain that's causing the issue. So you can have a bad chip because its outputs are bad, or you can think you have a bad chip, as I just did, thinking big here, because the input on the next chip is shorted. So let's go back to the schematics here. So I'm looking at N2 right here, and I discovered that with a newer chip, it looks like it's struggling to try and count. It couldn't quite do it. So my next things that could be the issue here are outputs from that. So there's an interesting method you can use to figure out if there is a short, where it could be. So I'm going to go back, turn this on again. So what I can actually do, I can actually measure from a signal to ground, and if it's somewhere near 0, I know there's a short, and you can actually check around the board, and whatever has the lowest resistance is likely the problem. So if I start, I know that, so this pin 13 here is my problem. So 8.8 ohm is the number there. So back on the schematics, if I follow this is the pin, so that's 2, 14, 13. This is pin 13 here. If I were to follow this down, and then go over, and then go down and go over, so M4, that's on pin 13 as well. So I go over to M4 on the board, which is M4, so a little bit further away, and I check it again. Make sure you guys can see that. And I check it again. 9.2. So the idea there is that it looks like I'm actually getting further away if I go in this direction. So if I go in the other direction, what I actually find is the other place that this bad signal goes to is this SO4 right here. So at N1, 74 SO4. This is actually also involved in generating the main clock signal anyway. So that's right up here. That's this chip up here. So I'm going to remove it. And we're going to talk about families of chips later. So this is a 74 SO4. Can I... Let's see, this is a manual focus camera here. Can I get it close enough to read it? DM7404, 74SO4. Okay, so when I was actually doing this repair, let me get back here. I didn't have a 74SO4, and so I actually thought what I should be using is a 7404. This was a mistake, but I'm going to put it in because I made this mistake. So I thought, oh, should I be putting in a 74 LSO4? Low power, maybe that won't work well at higher clock rate. So I'm going to put in a 7404, which is non-Schottky and non-low power. And it's going to work. But we're going to come back to this later. I promise you. Okay. Turn it back on again. So now I've got a measurement on, man. Okay, finally we're back. All right, sorry about that, everybody. This is what happens. Okay, so our pin 14 was working. Now our pin 13 is working. And 12 and 11 aren't flipping, but if you look back at the schematics, they are actually not connected, so that's fine. Okay, so now we can move on to the next thing here. Let's take a look at the monitor. Where's the monitor? CRT cam. Okay, so now look at that. We have an image. So bring up the CRT. So now basically we're at a point where the video circuitry is working well enough that it can do something. But when you get a screen like this, so you get a screen that has kind of solid background, kind of garbage on the screen, you probably have a good idea that your video circuitry is working, but your CPU is probably doing nothing at all. So let's move on there. Okay, so we can take a look at the schematics again. Now we're going to go to the actual CPU side. So, you know, we're kind of happy that the synchronizer is working. I had a solid sync signal. I didn't check it again, but because the CRT worked, I know it's working. So you go look at the microprocessor section here. There's our 6502. So very often, one of the first things I do when I work on these boards is I just replace the CPU with one that I know works, and then at the end of the repair, I'll put the old one back in if I feel like I want to save the new one for something else, because, you know, it's better to have new ones at your disposal to replace ones that are actually broken. So I would typically just replace it, but in this case, we'll take a look. We'll actually see if we can figure out why it's necessary. Arcade nut knows here, dead CPU. Okay, so the check I actually did was, let me move this up here. So here's a 6502. The check I actually did, I mean, you can go through, you can kind of look at all the different signals. A lot of things are just kind of stuck high with that. That's pin 3, so that's got a signal on it, but that's, I don't even know what is on pin 3. Something that is not enumerated on the schematic. But for example, something important. Okay, so we'll look at like, say the read-write signal up here. So pin 34. So I'm going to count. I'm going to count back from 40, 40, 39, 38, 37, 36, 35, 34. So 34, we've got nothing going on. We've got a dead signal. If it's not reading and writing, then it can't possibly be accessing the RAM or anything like that. I could also check the reset signal, which is pin 40 on a 6502. And this is what you'd expect to see. So the watchdog circuit, which is a circuit that fires to reset the CPU continuously until it basically is told otherwise by a working program, you can see that it's going up and down on a regular cycle. If I go way back, you can see it's about, I don't know, 5 or 6 times per second. So CPU is not running. So let's pop in a new CPU. Turn it off, of course. I'm going to remove the CPU here. So this is an SY6502A. Again, there's classifications. So 6502A is faster, so it can handle higher clock rates without failing than a regular 6502. So you have to make sure that you replace it with another 6502 that is rated highly, at least. So this is 6502AD on it. I'm actually not sure. I know it works with this board. I'm actually not sure if the A or the D is the speed indicator. I think it's probably the A, and the D probably indicates either the dip packaging or the plastic packaging. This is gonna do a little bit of an aside here. So this is a chip that I got from China. I often buy, sets of 5 or 10 CPUs, RAM, all that kind of things from China, and they've all started arriving in this kind of suspicious-looking package where the pins are shiny and they have solder on them, and the top is not engraved, and it looks like it was just newly stamped. And it doesn't make sense. So the date code on this is 4285, which I think corresponds to the 42nd week of 1985, which could be when this was produced, but the stamp that's on it doesn't make sense to be there from that time. So people have been calling these counterfeit chips. They're not counterfeit. They're probably just old pulls, and they've been sanded down, stamped, and they may not have the right rating. But usually for the price of this kind of stuff, I'm okay to give things a shot, basically. So I did get a set of 74 LS244s that were all dead recently. Had to throw them all out. Okay, so let's stick in a new CPU. Let's give it some power. No, nothing really changed. So did we really do anything? Well, let's check that pin 34 again. 43, 93, 37, 36, 35, 34. So now on pin 34, we actually have a signal. Look, we got a little bit of activity in there. Every watchdog cycle. So now the CPU is running. That's great, but we still have no game, no activity on the screen. It's not getting very far at all. So my next idea now is to check the buses. So you have to make sure all the addresses get out to the rest of the board, and you have to make sure all the data gets out to the rest of the board. So back to our schematics here. So you can see that on C1, this takes addresses 0 to 7 and sends it out to the board as a bus called AB07. B1 does a few more, A8 up to 12, plus it also sends through some other signals here. And then down at the bottom, E2, this is bidirectional, obviously, because you have to get data in and back out. So I started here. I thought, let's take a look at this DB. Obviously, if data can't get out and back in, then there could be issues. So here's what I did. I went to the board. I found that E2, which is right here, and I started checking the bus signal. So 2, all good. 3 was fine. 4, 5, 6. I got to 9, and I got this strange signal, and I didn't like it. And I thought to myself, this really looks like it's shorted somewhere. So, I mean, if I zoom out a little further, it really looks bad. Let me see if I can actually get, I'm going to make this a little bit bigger just so we can kind of zoom in. We're going to move over on the, we're going to move over. So take a look at this here. Let me do a single. So this looked really bad to me, and I would say most repair guys would look at this and say that doesn't look great because it's not really going down to 0 and it's not going up to 5 volts very often. But it, you know, as it will turn out, the few times that it does, so you can kind of see. I can't really point at it here, but you can see that there is one little signal that makes it down to 0 volt, and you can see one towards the right that makes it up to 5 volts. So this is actually just acting really weird. It's just resetting. It's not settling on anything useful. So unfortunately, what I did was I went around the whole board and I took out every chip that was on the DB7, which was that pin 9, thinking I would find a chip that was stuck. So I actually went through everything and there was no problem. So that was, you know, quite a few chips. I had to take out half the video RAM chips. I was lucky to find that one of the main RAM chips was bad, so at least that was an opportunity to switch that out. But that actually did not turn out to be the problem. So what did I do next? So actually I'm going to change that RAM chip now because this is the time when I realized it was bad. So that is this, oops, throwing stuff around here. So the main RAM is a pair of 2114 SRAM here and here. I actually just replaced both. They both tested bad. Let's do a test. We can do that. So let's pull them out. There's one. There's the other. Let's go over to the test section, test bench, and we'll test them with a Neolock Inquisitor. I'm going to make this a little bigger so you can see it here. There we go. So this is the Neolock Inquisitor. This is a great system, and it just changed hands. The original people who made it, they don't sell it anymore. They sold it. If someone in the comments knows who it is, let me know. It's Pinball Life or Pinball Resurrection. I'm not sure what the actual name is, but it's great. It has these blades that you plug in, and each one does a different set of RAM. So I have in the SRAM blade here, and I can actually set this to 2114. So let me grab. We're going to put that in there, take a check. There, so it said bad. So it went through to the test, no good. Check the other one. This one was actually good, but I decided to replace both just because I have a lot of them. I'll keep this one as a spare maybe, but if it's the same vintage as one that broke and they're cheap, you might as well replace it. So one was good, one was bad. I replaced both. Okay, here we go. So these are, oop, that's the wrong type. Oh, you know what? What did I do here? I actually did only replace one, so I only have one here. So I'm gonna have to go figure out which is the bad one, because I can't go putting in the bad one here. Just checking. This is a good one. Okay. Okay, so I'm gonna put that in there. This is for my own cabinet, so if things go squirrely in the future, I'm just gonna fix them. If I was gonna sell this board, I would just replace it because it's not that necessary. Okay, let's turn it on again. Still nothing. Okay, that's kind of disappointing, right? So at this point, I was thinking, okay, I guess it's not this DB7 that's causing the trouble. I guess I'll go back through and I'll check the address pins now. So I go back up here and I'm going to take a look at C1 over here, and let's see what we get. So this is pins 3, 5, 7, 9, 18, 16, 15, 14. So let's go back to the board here. So this is down here. This is C1 here, and this is B1 here. So we're going to take a look at the scope. Okay. Okay, we're back. Okay, so let's take a look here. So I'm going through on this C1. If this was faster, I'd ask you to stop me when you saw a weird signal. Okay, look at that. That is ludicrous. So that is going way up to like 6 volts. It's stuck in the center. That is obviously our bad signal. So what this is on pin 12. So we take a look at the schematics here on pin 12. 12 is the output for AB0. So there's going to be, again, a ton of stuff on this that could be the problem. So I'm looking around the board, and of course this is actually used all over the board. It's used in the RAM and the ROM. You can take that out at least. You can remove all the RAM, you can remove all the ROM, and you can check it again to see if it's settled down. But I was thinking, you know, it's weird that it's kind of stuck closer high like that. And then one of the things that it was connected to was the output coin counters. So if you don't know, arcade machines usually have a coin counter in them, and they operate on higher voltages via transistors. So I just had a hunch that it could be over here, and it's this AB0 here. So this is M10. It uses that signal there. So up on the board, let me turn off the CRT cam for a second here. So up on the board, this is way over here by these transistors. So I just had a hunch, and I was lucky that indeed that was a broken one. So it could have been like the other. It could have been like the data that I was looking at. I could have had to take out every chip that was connected to AB0. Luckily, I had a hunch on it. This one, I tested it, and it was bad. And if you have something on the address bus that is causing trouble, then nothing else can operate. No ROM, no RAM, nothing. So now we have our new 259. I'll place that in here. Okay, so that is replaced in up there. Now let's take a look and see what's going on. Turn it back on. Hey, look at that. Turn up some brightness on here. Does that look great or what? Okay, it doesn't look great. So now we can take a little bit of stock here. So we have the CPU is running fine. It's not resetting. That's good. There's some issues. Again, if this was faster, I'd ask you guys to tell me what's missing here. But what is missing is the mushrooms. There's no mushrooms on the screen. I happen to know that is the fault of the Pokey, because I've worked on a bunch of centipedes before, and one thing I usually do is simply remove the Pokey while I'm working on it, because I know it's not necessary and it's just one more big chip that can cause trouble. So, unfortunately, the Pokey is broken on this board, and it's unfortunate because it's a chip that they made a lot of them originally, of course, but they're hard to find now. Kind of like a $40 chip, which is a bit annoying. There is an FPGA replacement available, the Pokey 1 chip. In the comments, if you've used one successfully, let me know. I was thinking of getting a couple just to have around. One secret tip is that some bootleg Tetris boards will have 2 Pokeys on them, which is a gold mine. So I kind of watch eBay once in a while and might grab one. They seem to come from like Greece and Argentina and whatever. But that's a secret source, so shh, don't tell anyone. I think the Pokey ones, if they come down in price a little, they'll just replace them all. So let's replace the Pokey. Okay, so I turned it off there. Never, remove chips while it's on. So the Pokey is this one here. I'm gonna remove it. I can't test this directly, but I mean, I just did. I know it's not working. So this is the AMI version, part number C012294B. I'm going to replace it with a much newer looking version that I got from some other board. I can't remember what. It might have even come from a real Tetris, like a Atari Tetris. So let's pop it in there. Okay, so now we're even further. Now we have our mushrooms back. That's good. So next thing to remember is that a lot of these boards, especially Atari boards, have test modes. And the test mode uses the fewest amount of resources to be able to tell you things that the company thought could go wrong. So the biggest one usually is video RAM. So if you want to figure out if it's the video RAM is causing this glitch you can see on the screen, you can use the test mode. So I'll press the test mode here. I didn't hear any noise. And usually you get tones to tell you if any RAM is bad that it tests. The manual explains all this, so you should look at the troubleshooting section. The manual tells you if you hear one beep, it's this one. So what I would normally do here is I would actually, if I have socketed one already, I would remove a RAM chip so that I can hear the test tone and know that the test mode is working. So I'm going to go in here and I'm going to remove RAM 4 here. And I'm going to turn it back on. Oh, I did what I said you shouldn't do. I removed a chip while it was on. It's fine for RAM, really, but you could always risk shorting something out. So, pretend I didn't do that. So I'm going to hit the test button. Now, I didn't hear any noise. And the test mode is not showing up very well. So, if I didn't get the noise, that's weird. So now I'm thinking there's got to be something wrong in the audio section. Joe, yes, I have got some from Greece. Some PCBs from Greece. Yeah, they have a bunch. They're always bootleg, but they'll probably be broken. If you want them for parts, that's a good idea. If you see them working, it's probably fine, but I wouldn't count on them. I got a few from Argentina. There was a guy selling a whole bunch of boards. I got a couple bootleg gyrus boards for my little mini arcade machine that I built. It all came fine. I mean, you can trust most people around the world. No problem at all. ArcadeNet says Atari 5200 cartridges such as Ball Blazer have a pokey in them. Yeah, Blazer has gone up really high. Okay, so now I think there's a problem with the sound. And I just replaced the pokey, so I would assume that the sound is probably working. So let's go over to the audio section of this board, of this schematics. Here we go. So the pokey, the C012294, this is the chip that does all the sound on the Centipede board. And the output from there is 37. So it looks like the oscilloscope is still running. So let's check pin 37. 37. And I hit the test. And I'm looking to see if I get a signal, and I can see that I'm getting deflections. So if I slow this way down, you should be able to see it. I'm going to bring this down here. I'm going to bring this up high. That's a little too much. So when I go into test mode, you'll see it deflect. Bing, 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 bing. So those are actually the 4 tones being played to tell me that the 4th RAM is bad. So now I know I've got an audio issue, but I know the audio is working from the pokey because I just saw that it was producing little square waves. So let's take a look at the schematics. Yeah, right, Joe? I know, this is crazy that there's so much wrong with this board. This is a beautiful board. I bought the machine. It appears to be an Irish cabinet. Not sure what it's doing in Canada, but I bought it from somebody, and it has a bit of a different color control panel. It has a stainless steel control panel. Coin door. It has the art is a little bit different on the sides. Apparently this is an Irish cabinet from searching around. It's kind of interesting. But yeah, the board is beautiful. I don't know why there's so much wrong with it. Anyway, so next thing here, there's not much in this circuit for audio, right? Because the actual amplification is done on a separate audio board, the AR2, Audio Regulator 2 board. So there's not much in here. All we really have is all this, these passives. Like I could be checking the capacitors and I could be checking the resistors. But really, I'm looking at the op amp, which is an LM324, super basic. You should have these in your toolkit. And I certainly did. So my first thought is just, go in there and replace it. So that is up here, LM324. So let's replace that. Come on. There we go. LM324, still made brand new, of course. Very cheap. You know, 50 cents from DigiKey kind of thing. Pop it in there. Okay. All right, so now, test mode, do we get noise? Okay, that was good. So now I know that test mode works, but it's reporting a bad RAM, and that's because I took the RAM out. So let's put the RAM back in. And let's check our test mode again. Okay, so now we got the test mode up. Looks like most things are working, but there's supposed to be a sprite in the middle of the screen, and it's not there. There's a little tiny flicker you can see, but that's not going to cut it. So let's take a look. What's going on next? So, if we know the text is working, we know the mushrooms are considered background tiles, I think. So basically, it's only the moving objects, the sprites, that are causing trouble. Luckily, there's a section in the schematics called moving objects, so let's take a look at that. So we're going back to the third sheet here, and down here you see motion object circuitry, vertical and horizontal. And we're not gonna go through all these signals, but I can tell you I checked through all these signals. They all seemed healthy. This was all going good. All these ships seemed fine until I got over here. And down here, I remembered when I got there, I should have checked this earlier as well. There's some RAM down here. So this is 27 LS00, which is equivalent to 74S201. You should always take a look at the tables online to see what equivalents are. So I happen to have 74S201 sitting around, so that's what I was going to use. The Neolock does test them. I'm not going to bother testing them just because we've already done a couple tests. So I'm going to turn this off. And we're going to replace this RAM, which is over here. Neolock is great. Oh, somebody in the comments said, oh, Patrick told me it's sold by Pinball Classics. I do hope they continue to develop it. There's some missing things. I have the SRAM board, the 4116, what is that, DRAM, and the 9060 DRAM board. Okay, so that goes in. And this one goes in. Now we're hoping for those sprites to be fixed. What do we get? Okay, look at that. So we're better now. We've got our centipede up top. We've got our little guy at the bottom. But this is kind of hard to see. I thought it would be more obvious on the board, but they're sparkling. They're not complete. We're missing things, especially if you see. Actually, you know what? Test mode shows it really well. So you see that like bar in the middle? That's kind of let's go bigger. So you see that bar in the middle? That's blue and purple. So that's supposed to be all one color, except for two little spots at the top. So it's obviously not pulling things on. Arcade Nut, if you're talking about the CRT, yes, this is a real CRT. I don't have a capture card that can do this. There we go. I'll just defocus it a bit so we don't see the Moire pattern so bad. So see this in the middle where you're seeing kind of purple? That should be blue, I think. And what I noticed was if I take my hand and I kind of like hug the chips I just replaced, those RAM chips, it fixes it. And then I let go and it goes away. I was thinking, what's going on here? The RAM I have is brand new. I checked the data sheets to make sure they're fast enough, and they are. So I was thinking, and I was looking at the look at the schematics here, and you see that it actually makes use of the 6 megahertz clock all around here. I can't remember where it is. So I was thinking, you know, way back when I set that that first chip at N1, the 7404, and I decided not to use the 74S04, could that impact the game enough to cause this trouble? Because it's working otherwise. I can play the game right now. I just have these lines through the sprites. But Indeed, I was wrong. So I did find a 74SO4. This is from an old board. This isn't a brand new chip, unfortunately. But so I'm going to replace the 7404 that I did have in there with the 74SO4. So, you know, this is some good reading you guys should do. Look up the Wikipedia article on the 74 series and see what they all do. It's kind of interesting. It gives you some insight. So the S series has Schottky diodes. So the idea is that it actually goes on and off faster. Like the slew rate between it turning on and turning off is faster. So obviously that's helping with the synchronization of this board. The L, so if it's 74LS, the L stands for low power. So that's the difference between the LS and the S. So an LS may have worked in here. I didn't try it, but I did find the S, so let's just stick with the S. So turn it back on. Okay, now everything is solid. And I checked the test, and it's good. There's nothing is going on here. No sparkles. Okay, so let's I think we're almost there. So let's grab the trackball. So I have a trackball with an adapter that plugs into my circuit board adapter that I have here. I'll plug that in. And I'm also going to I use my Neo Geo controller for the buttons, so I'm going to plug that in as well, just for the fire button essentially. But okay, so let's coin it up. Their credit worked. Press start. We've got sound. Hopefully you can hear it. And let's check the control. Yep. All right, we're all good. It's a little delayed to actually see it on the screen. Okay. Okay, so that's it. We're at the end. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chips that were bad. That were actually 9, because that 163 at the start that I thought was bad, and I tested it and it was good, and I thought, no, I told you guys, oh, that's bad, and then I realized, no, it's probably good. It was actually the 7404 after it that was causing trouble. So, live and learn. Thanks everybody for watching. I'm going to do a couple more videos, some shorter ones, kind of on incidental things that were going on. For example, I was working on a Tron board the other day and came across some information that can be pretty useful to people about RAM speed. So I'll do some little videos here and there. If you have any boards that you kind of want me to look at, let me know on the show. I have a ton of Asteroids boards to fix, but again, none of them are ones that I own. So if I get one, I'll probably do a show on that, because it's a really crazy board, and vector stuff is a little bit different. So that's pretty neat. Can't wait to do it. So that's it. This thing in the back, this Popeye is running on a Mister board. I'm going to do some videos about Mister. I think it's a really neat project. FPGA, open source, great emulations of software, and it's going to change how people think about PCBs and whether they're more for utility or collecting. I think it's going to change things in the future. So if you want to see anything on that, let me know. And that's about it. So I don't think I see any questions in the chat right now. So I'm going to pack it up, leave some questions in the comment, and I'll get back to you then. Until next time, thank you for joining me.